Da-da-da, da-da-da, LHS Sports Science.
Welcome to LHS Sports Science, discovering the math and science behind Langley Athletics.
Today we are taking a look at Langley's most prestigious and athletic student athletes, the golf team. These marvelous young men must combine precision, accuracy, and strength to properly hit the ball the distances that each course requires.
With our state-of-the-art technology, we will find out how these young men rose to become state champions.
So here we have Mr. Thrasher and Johnny Boy.
Yeah. As golfers, we're very keen in the field of mathematics. For example, on a 60-yard shot, I know that I have to hit the ball at exactly 43.27 feet per second at 42.5 degrees of launch angle.
Eli's obviously joking here, but there is a lot of math hidden in golf. Today we'll show you that.
We'll show you how it's done.
So today, we're going to be taking a look at parametric equations and how they relate to golf. They're pretty simple. For x, the position and result of time is equal to the velocity of x times the amount of time, and the position in relation to time in the y direction is equal to the same thing, the initial velocity of y times time, but it's added with half the acceleration times the time squared. We'll get a look at the next part too. So, with our golf ball, you will see that it launched at degree theta with part of the velocity in the y direction, part of the velocity in the x direction. Our theta, which we'll show you, was measured at 38.5 degrees. The velocity, measured by the distance over time, shown in the video, is 19.63 yards a second. So, getting the x and y is pretty easy. The velocity in the x direction is simple. Cosine of 38.5 times 19.63 is equal to 15.35 yards a second. And the y direction is sine of 38.5 times 19.63, or 12.23 yards a second. So, the first thing that's important in golf is finding the distance the ball travels. And that can easily be found using our first parametric equation. The position x and result of t is equal to the initial velocity in the x direction times the amount of time that's passed. Our initial velocity, 15.35 yards. Our time that was passed, well, we measured that. It was 2.28 seconds in the air, which leads us to a total distance traveled at exactly 35 yards. A very important number for golfers to know. The second part of hitting a golf ball is knowing how high to hit it, right? How high do I need to go to maybe go, over a tree or possibly under a branch? Excuse my poor drawing. This one is a little trickier. We're going to have to use the second parametric equation and our good friend calculus to help us. So, we have our equation y as a result of t is equal to VOY t plus 1/2 a t squared. What we're going to have to do is our favorite, the derivative. So we're going to take the derivative of y in relation to t, and we're going to get the original velocity in the y direction plus, do the 2, the acceleration times time. So when we plug in these numbers, we're going to have to find the minimums and maximums. So we're going to set that equal to 0, and we'll start plugging in some numbers. The original y velocity was 12.23 yards a second, plus the acceleration due to gravity in yards a second is negative 10.73 yards a second. And that time ends up being 1.4 seconds. So, all you do, plug it back into the equation. The position of y is equal to the initial velocity, 12.23, times the time, 1.4, plus 1/2, 10.73, times 1.4 squared. And when we add that all together, you get so when you end up doing all the math, you get that the ball went at its max height of 6.61 yards.
Which makes sense.
Golf is secretly just calculus. That's it.
As we can see, math is a very important facet of the golf sport. It is actually 90% math, 10% skill.
You can use parametric equations to figure out how far the ball will travel, how long, and how high it will go.
This is fine, gentlemen, for showing up here today at Sports Science.
Enjoyed it. Pleasure. Thank you.
Until next time.